So now we start our final module, Module 11. And this is actually going to be reminiscent of things that you saw in Math 21A. We're going to look at things that relate to exponential graphs and also to linear graphs, things that we saw in Modules 3 and 4. So this does bring things back to what we saw in the beginning of this whole class. What we're going to start with in Lesson 11.1.1, Statistical Models and Mathematical Functions. As an introduction, Sarah is planning to start Austin Community College next semester. She plans to take 13 credit hours, or 13 units, we might say, at our school. Sarah needs to plan her budget. She wants to know how much next semester will cost. Students from Austin Community College were randomly selected to answer 3 questions. 1. How many credit hours are you taking this semester? 2. How much did your tuition cost this semester? And 3. How much did your books cost this semester? The data collected from the students is presented in the table below. Table A, credit hours and costs. So the first column on the left is credit hours. You can see that we have examples of 3 credit hours, 5, 6, 9, 12, 14, and 15. So those are increasing as we go down in the table. We also see tuition costs in the middle column. We can see on the low end 186, and then going all the way up to 15 credit hours, there's $930. And then book costs. And we can see that we've got varying book costs in that third column. Number 1 on the next page. Sarah needs to plan for the cost of spring semester. How could you use the data to help Sarah plan for the cost? Maybe think about it from your own point of view. After you've taken a couple of semesters of school, can you start to estimate how much it might cost the following semester? So maybe think of costs that she would have. Tuition and book costs. Some things that we would want to know is how many units or credit hours is she taking? She said that she's planning on taking 13 credit hours. So do we have any examples from other students that would show us maybe how much she would pay for something like that? We can see for 12 credit hours, it's $744 for the tuition. For 14 credit hours, it's $868. 13 credit hours is between 12 and 14. So we might expect that the tuition is between $744 and $868. Now, how about her book costs? Well, we've got for the person that took 12 credit hours, they had a book cost of $297, but somebody else who also took 12 credit hours, their book cost was $413. And then the person who took 14 credit hours, their book cost was $394. So a question you might have at this point with the book costs is, well, it looks like that is a little bit tough to judge based off of how many credit hours you took. And you've probably experienced this yourself. Book costs for, say, a math class might be different than for a yoga class. So if you think about it in that point of view, it sort of depends on what the classes are. So we could estimate, maybe we could notice that 297 is close to 300, 413 is close to 400, 394 is close to 400, so maybe somewhere between $300 and $400. We're a little bit less certain about that estimate than tuition, though. And that is going to be the sort of point of this whole lesson. So maybe the book estimate is between 300 and 400. Number 2, data from Table A is presented in the scatter plots below. Remember, we saw scatter plots back in Math 21A. Use the scatter plots to make the following predictions. So notice the first scatter plot, we've got a horizontal axis of credit hours and then a vertical axis of tuition. You can see that the credit hours are going from 0 on the left all the way up to 15 on the right, and the tuition is going from 0 on the bottom all the way up to 1,000 at the top. And this scatter plot, you might notice, it looks like things are pretty close to a line. Now the scatter plot on the right, again, just thinking of things we learned in Math 21A, we've got credit hours on the horizontal axis again, going from 0 on the left all the way up to 15 on the right. But the book cost, that starts at 0 at the bottom and goes up to 500. Those dots are scattered about, and you can notice that just by comparing these two graphs, remembering things we learned in Math 21A, it looks like the scatter plot on the right, the dots aren't so much in a line. There may be somewhat of a linear shape, but maybe you might say it's not as strong as what you see in the graph on the left. So number 2, part A, predict the cost of tuition for a student taking 13 credit hours. So to do this, we have to use the graph on the left. So we need to use the graph on the left. And if we think of how could we do that estimation, we could find 13 credit hours. Well, if there's a 10 credit hours and a 15 credit hours, then 13 would be somewhere in between, but it would be closer to 15, so we could say maybe 13 is there, and we could follow that up. And then where it looks like it reaches a dot that's somewhere in line with all of the other dots, we could then go over to the tuition, and it looks like maybe we could estimate at $800. So the estimate or predictions, $800. Part B, predict the cost of books for a student taking 13 credit hours. We can do the same sort of thing. We can make a mark on the credit hours similar to what I did for the graph on the left. So I'm using the graph on the right now. And I can start at 13 and I can go up to what looks like maybe is in line with the rest of the dots. And then I'm just estimating, making a prediction, somewhere a little bit more than $400. Maybe we could say $410. Notice what we're doing here is not calculating things exactly. We are making predictions, we are making estimates. Things we do all the time when we're just basing off of a little bit of knowledge. Number 3, look at your predictions for questions 2A and 2B. Do you think one of your predictions is likely to be closer to Sarah's actual cost? If so, which one? Explain your reasoning. This goes back to what I was talking about with these scatter plots. The graph on the left, the one that is using credit hours to predict tuition, the dots there are more in line with each other. So it's a little bit easier to make a prediction. Whereas the one on the right, when we have credit hours versus book cost, that's a little bit more difficult to make a prediction. So the one on the left, which is credit hours and tuition. And the reason why we would say that is because the dots are more in a line. Number 4, based on your predictions, about how much money should Sarah plan to spend next semester? Well, she would need to spend money on tuition, plus her book costs. And we're only considering those two things. Obviously, going to school takes more than just that, but that's all we're focusing on because that's all that they asked the other students about. Her estimate for tuition, about $800. Her estimate for books, about $410. So this comes to a grand total of $1,210. Next steps. The scatter plots below include their lines of best fit. So here we've taken the scatter plots that were on the previous page and we've just drawn a line that approximates what looks like is happening with those scatter plots. So we have the same scatter plot on the left, the one that is comparing credit hours to tuition. Here we have the equation of the LSR line, or least squares line, or line of best fit. That equation is y hat, remember that's the predicted tuition values for that graph on the left, is equal to 62 times x, where x is the number of credit hours. The correlation coefficient is r equal to 1. You might be thinking, wow, this is a lot of review of things that I saw in Math 21A. This is good because the final exam in this class does ask questions about what you learned in Math 21A. It is putting the whole class all together. Now the graph on the right, there's our scatter plot for credit hours versus book cost. The LSR line, or least squares line, there is y hat equal to negative 36 plus 32x. So the predictions y hat for book cost, you can find that by taking negative 36 and then adding 32 times x, the number of credit hours. There, the correlation coefficient is r equal to 0.94. Okay, so we have two different scatter plots, two different lines, and two different correlation coefficients. Number 5. Examine the least squares regression, or LSR, models for tuition cost and book cost. Part A. What are the similarities? So, thinking of things we learned in Math 21A, look at their correlation coefficients. R. The one on the left has r equal 1. The one on the right has r equal 0.94. Would you say that both of those are positive? Yes. Okay, so that's one similarity. Both are positive. What's another word that we learned in Math 21A when talking about least squares regression lines? Positive. How about strength? We would say for both of these that they are strong positive. And their lines, so both positive, strong, linear correlations. What can you also say? Maybe throwing in some other words that we talked about. How about the slope of the two lines? Both lines have positive slopes. If you want to remember what the slope of a line is, it's the number that's being multiplied by x in the equation that you see for the lines. Okay, what are the differences? If you look at these two differences, two lines, you can definitely see that while the correlation coefficients are both strong and positive, they do have different values. Okay, so the numerical values for R, the letter R, are different. The one for tuition is R equal 1. The one for book cost is R equals 0.94. Okay, what can we also say? How about if you look at their equations, do you notice that the one for book cost has a number that is then added to the number times x, the slope times x, whereas the one for tuition doesn't have something like that. That might bring to mind the idea of a y-intercept, or we would have called it an initial value. So we also have different initial values. All right, so now number 6. Use the equations for the LSR lines to make the following predictions. This is going to be something that we would have done exactly in Math 21A in Module 3. We're going to use equations to make predictions. So part A, predict the cost of tuition for a student taking 13 credit hours. So the equation that we need to use for part A comes from the scatter plot on the left, where the LSR line had an equation y hat equals 62 times x. Remember that y hat is going to be the output, the prediction that is made. But we have to put something into this equation. The thing that we have to put in is the 13, and it replaces the x. So this means that our prediction, so predicted tuition, that would be y hat equal to 62 times 13. So then if you multiply 62 times 13, you get $806. So that's our predicted tuition. Now let's do the same sort of thing for part B. Predict the cost for books for a student taking 13 credit hours. This time the equation is different, because if you go up and look at the graph on the right, the equation is y hat equal negative 36 plus 32x. Y hat equal negative 36 plus 32 times x. And again, we have to take the 13, which stands for credit hours, because that's our horizontal or x-axis. That gets put in for x. So the predicted book cost would be y hat equal negative 36 plus 32 times 13. You need to remember your order of operations here. What do I have to do first? Do I have to add negative 36 and 32? Or do I have to multiply 32 and 13 first? PEMDAS, you have to multiply first. So 32 times 13, which means you'll then have y hat equal negative 36 plus 416. And when you add those, negative 36 plus 416, you get $380. So the predicted book cost is $380. So continuing with these predictions, on the next page, number 7, when making predictions, which of these LSR models would you have more confidence in? Explain why you chose that LSR model. Which one would we say gives us stronger predictions? Which one has a stronger correlation coefficient? The one on the left, the one that has a correlation coefficient of 1. That is the strongest correlation coefficient in a positive direction that you can get. So, the one for tuition. And why would we choose that? Because R, the correlation coefficient, is equal to 1. And then finally, number 8, how does your answer to question 7 compare to your answer to question 3? Well, what did we say for question 3? We said the one on the left, the one that used credit hours to predict tuition. We were more confident in that for predictions. We just said the same thing in number 7. So they are the same. So this was a big review of something that we saw in Module 3. And now we're going to see how this applies to what we're looking at in this module. You need to know, when examining relationships between two variables, we have so far used only statistical models. That's what we've been doing for 10 modules, just looking at statistical models, which means models that are based on data. Now we're going to look at what are called mathematical functions. Mathematical functions are another useful tool. Here are the differences, or the definitions, I should say, of each. First, statistical model, what we've seen so far. A scatter plot of the data will show a pattern. It's possible that the pattern shows more than one y value corresponding to a given value of x. So this is one thing that we want to focus on for statistical models. We could have more than one y value corresponding to a given value of x. We can use a LSR model to predict y, the response variable, but the prediction is only an estimate. The prediction is likely to be different from any observations with the same x value, which we also call the explanatory variable. So that's what we've been learning with statistical models. Now, mathematical function. A scatter plot of the data will show a pattern. Okay, that's the same as a statistical model. Now here's something different. Only one y value can correspond to a given value of x. We can use the function to predict an exact value. It won't be an estimate. We will predict an exact value for y. Predictions are always equal to observations with the same x value. So now let's see this you need to know box with these definitions for statistical model and mathematical function. Let's see how that applies to the example we were looking at in this module, this lesson. Number 9. Use the scatter plots for tuition cost and textbook cost, the ones before question 5 above, to answer the following questions. Part A. Is tuition cost per credit hour represented by a statistical model or a mathematical function? Well, let's go back to what we saw with those scatter plots before question 5. So if we're taking a look at that scatter plot, there's the ones with the lines before question 5. You can also just go one page previous and see the scatter plots without the lines. But maybe let's ask ourselves, with the difference that we saw in the you need to know box, do we see with credit hours and tuition different tuition values for the same number of credit hours? No. For any given credit hours, there's only one tuition cost. So we can write that fact down in part A. For any given credit hours, there is only one tuition cost. So because of that, this relates to a mathematical function. Only one y value can correspond to a given value of x. So this is a mathematical function in part A. And before we go on to part B, just think of this in your own life. You want this to be true. Do you think it would be fair if you took the same classes as your friend, but yet the two of you paid different tuition costs? That wouldn't be fair. Or let's say you take a different example. You're out of school and you're just going somewhere and buying a cup of coffee. Would it be fair if you walked up and paid a cost for a cup of coffee and then your friend walked up, bought the same cup of coffee, and they paid a different price? No. You want those costs to be the same. We depend on things like that. So this is a typical function that we see in life. But now let's look at part B. Is textbook cost per credit hour represented by a statistical model or a mathematical function? Explain your reasoning. So now if we go back up to the scatter plots, do we see for the same number of credit hours different book costs? The way that you can recognize this is, do you see some dots that are in a straight vertical line with each other? You do. And in fact, if you go back to the table, you can see that, let's say for 3 credit hours, look at the outputs. 9 credit hours. For 9 credit hours, notice the book costs, 247, 188, 165. So for the same number of credit hours, there are different book costs. Also, you can notice the tuition's all the same for 9 credit hours. So when we go back to number 9, part B, is textbook cost per credit hour represented by a statistical model or mathematical function? It has to be a statistical model. Because for any given credit hours, there could be, and there in fact is, more than one book cost. So for any given credit hours, which was our X value, there are more than one book cost. We see that in one example. There are a couple of others that are doing that in our table. So notice it's possible that the pattern shows more than one Y value corresponding to a given value of X. That's what we saw in the definition for statistical model. So this is an example of a statistical model. Notice book cost, that was the Y value that we were talking about in part B. So then finally, number 10. For both questions A and B below, read the descriptions of the relationship and then answer the questions. Will the relationships be described by a statistical model or a mathematical function? So now these are different examples than what we were just looking at in this whole lesson. Part A. The cost to fill a car with regular unleaded gas at the BP station on the corner of Watt Avenue and Fair Oaks Boulevard on May 31st, 2012. At this BP station, the price per gallon did not change that day. Let's compare that now to Part B. The cost to fill a car with unleaded gas in the United States on May 31st, 2012. To answer which one is a statistical model and which one is a mathematical function, how about we just ask ourselves this? With Part A, is it possible that for however many gallons of gas that we got, the price per gallon would change at that particular gas station on that day? In Part A, it says the price per gallon did not change. But now how about Part B? Is it possible that the price per gallon of gas could be different in different parts of the United States? Definitely. If you have ever lived anywhere else, you know that gas can be different than what it costs us here in Long Beach. So, the cost can vary at different stations. So for any given amount of gas, you could pay a different price in different gas stations in the United States. So this is a statistical model in Part B. Whereas in Part A, the price per gallon did not change at that one gas station on that particular day. So there's only one price on this day. So for any given amount of gas, you're only going to pay the same price. So if you come in and buy 5 gallons and your friend comes in and buys 5 gallons at that one gas station on that one day, you're both going to pay the same price. So this is a mathematical function in Part A. Also notice how I answered this question. I didn't have to answer Part A first. I didn't have to answer Part B first. I can look at both of them and make a comparison and then just start writing an answer down for both of them. All right, so that finishes this introductory lesson to this module. The secret word for this lesson is function.